So hello guys, welcome to the new video. Today is the day 2 where we will be learning Kafka. So in the first video what we have went through is we have went through what's the difference between EDA, which is driven architecture, versus REST API architecture. We saw that how event driven architecture is better than REST API architecture, and we saw that how efficiently we can use the event driven architecture and why it is useful. Also, yesterday's video was I saw that there is a some blurriness in the video. Also, the audio part is not quite good. So, what I thought to use this headphone for the audio, and also I have done some settings to see whether this video quality gets increases or not. So, yeah, without wasting our time, let's jump into our today's topic, which is Kafka architectures. So again, this is a video, this is a PDF which I am using as a source, which is was given by Concept and Coding by Shreyans. All credit to him for this PDF. Okay, now jumping into the topic. So yeah, in EDA introduction part, we have already seen what is pub sub model and what is streaming model. So we saw that there was a publisher subscriber model where a consumer can subscribe to any of the topic and producer can publish the event to the topic. Coming on to the streaming model is a model where you can publish your message and it will be staying in your memory, and you can retain it also. There is a retention policy available that till how much time it will be retained. But yeah, this is like short summary about PubSub and streaming model. Coming on advantage of EDA. So, like yeah, what we seen, what is advantage of EDA. Now coming on to what we will do today, we will start learning about Kafka. It's the most important thing which usually helpful in microservice event-driven architecture. So we'll start with what is Kafka. We have learned many things about Kafka. So as per I remember, Kafka was built by LinkedIn. Now I got to know that they have discontinued using Kafka because uh, it was not sufficient enough that uh, they were able to handle their events and messages there. So yeah, now coming on to yeah, what is Kafka? It's a distributed event streaming platform that allows us to publish event, store event, and subscribe to event. So what it is, it's a platform, or you can say that it's a pipeline kind of structure where we have different container inside the pipeline. So and where you can publish the event, you can just put water inside the pipeline. You can store the event, yeah, we can store the water inside the pipeline as well, and we can also subscribe to the event. So suppose our borewell, whatever it's coming, whatever water is coming from the government, it's like we are subscribing to that particular pipeline. So yeah, in Kafka we have something called as producer. So producer is an application that publishes event to Kafka. So yesterday we got to know what is event, something which happened in the past. We can call it as event. And what is producer? Suppose you have one of the microservice and it's published some event inside the uh, uh, Kafka. So it's called producer. Indirectly, if you can say, if you will take the water example again, that the machine which used to pull the water from the borewell, and it pushes to pipeline. That is called producer there. So producer does not care who will consume this event. So whenever we push some event to some platform, some random platform, we don't know who all are going to consume it. Our work was just we need to push that event. So yeah, producer doesn't care who will be consuming this event. Coming on to the topic, consider topic as a category or folder which events are published. So if we take example, there is a folder name called uh, Java, and inside that we have written many programs. In the same way, topic is also a place where events are being published. So this is the producer, this is the Kafka cluster, and inside we have one topic, and producer one is publishing that particular event inside the topic which named as order event. Now many products can write to same topics. Many producers can write to same topic. Yeah, like one, like there are multiple producer and they can write to same topics. Now things are becoming little bit interesting. What is partitions? So partition are physical or ordered and append only log. It is very important. Append only log, that is part of topic. So this is, we have full topic, and this we have partition. Partition 1, partition 0, partition 1 and partition 2. And remember, partition is a physical order and append only. So it's like there inside your OS memory, and it's like physically it's up here, it's there in your OS or server wherever it is, but it's physically stored there. Now a topic can have many partition, as we can see P0, P1, P2. Now if you see here, physical events are actually stored on disk inside the partition. So if you'll see, it's properly stored in the disk, like suppose we have a pen drive, so it's properly stored there. Topic, suppose we have a topic called order events, and partition 0, order event 0, partition 1, order event 1, and partition 2, order event 2. Now if we come to ordered, so if you'll see, physical, ordered and append only. So ordered events are written in sequential manner. So whatever come first, it will be written first, then second, then third. It's like fully sequential manner. Like whatever come first, it will go, then the second, then third. But consumer read them in offset order. So this is called offset. Inside partition we have something called offset. So if you know about array we have index 0, index 1, and like that we have offset 1, offset 2 inside the partition. Each partition have their own offsets. Each partition maintains next offset counter, whatever I said just now. When a new event arrives, Kafka assign next offset to that event. We understood? When a new event is come, whatever is the next particular offset, it's there, it will assign to them, and append the event to the log. You can see it will be always come after this, it will be in appending manner. Within a single partition, order is guaranteed. Yeah. So suppose we have only P0, so order will be guaranteed. E0 will come here, E2 will come here, E3 will come here, E4 will come here. Means that events are written in sequential and reading. Kafka do not reorder the event in partition. So once it is ordered, that means it is fixed there. It will not reorder it once again. Okay. So but do not guarantees order globally across multiple partition of the topic. For example, in partition 0, which is P0, we know that event 3 happened after event 0 because offset 2 comes after offset 1 in that partition. So if you'll see, yeah, event 3 happen after E0. But I cannot guarantee that event 4 in partition 1 have happened or before event 0 in partition. So suppose if it is one partition, it's okay that it will come one after another after another. But suppose there are multiple partition, we don't know this particular E4 happened after this. So we don't know that. There is a chance that this E4 happened before E3. So now we come on append only log. So what is append only log? So if you will see here, we have a producer, we have same topic, and inside topic we have the three partitions. And if you will see the partition offset one inside the partition, each partition have their own offset. And if you will see here, offset 1 event 0 JSON is there, and offset 2 event 3 JSON is there. So if you will see there, it's like appending one after another. So let's say a new event E5 at partition 2. So now E1 and E4 is there. So how E5 will come in P2? So E2 is there, sorry, partition 2 right here. So only E2 is there. Now E5 will come and just sit here. It will not replace the E2. It will be coming after. So file is appended with a new event and incremental offset manner, and everything stored in the log file, everything inside the partition. Now let's go one more level deep. What we understood till now? We understood we have Kafka. Kafka have producer. Producer publish the event inside the topic. Topic have partition P0, P1, P2, and partition have their own offset. And it's run under the manner of, if you will see here, where it is, yes, physical, ordered, and append only. Now if we'll come more deeper, we have something called as segment. Yeah, here we have this partition log file is further divided into segments. So what is segment? So if you will see here, suppose we have a topic called order events. Okay, understood? And it have the partition 0 P0. Now if we'll come here, it have one of the event called order event 0, and segment is like it's storing from 0.00 log to 499. So what we can understand here, suppose segment is something is starting from offset 1 is there till 499, we can call it as one segment. So if you will see here, segment is something stores the event with the offset 0 to 499. Then what is segment 2? It's like store the event with offset 500 to 999. Segment 3 stores the offset starting from 1000 to whatever it's present. So why we need segment? We understood offset was there, but why there was need of segment? Why to introduce too many terms here? So suppose consumer is saying I want to read from partition 0 of the order event 550 to 800. Now suppose we have one big log file for each partition, as I said, big, like from 0 to 1000, only one log file is there. Now consumer, what we have to do at that particular time, it have to read from 0 to 800 one by one, and it will not able to read it very fast. But Kafka is known for being fast, like lightweight and faster things. So instead of it, what we do, we chop that particular log file into some segments. So that segments, we will see that 0 to 499 offset will stored in this particular segment, which is first log file. Then segment 2 will be another log file. So we got to know, okay, now which log file, which segment we have to jump, and we'll able to fetch that particular offset very easily. Same thing is written here. Now we can control the segment size too. If I keep the size of the segment as 1 GB, then again sequential search in 1 GB segment will also take time. That's why it further maintain index file per segment. So if you'll see here, segment 1 is there, 0.00 log, like that, stores the event from 0 to 499. Understood? Now segment 1 also contain the index. So if you will see here, offset is 0 and offset is 150. So currently it's like 400, 4200 bytes it taken. Now 300, 900 byte, 450, 1320, which is more than I believe 1 GB. Not so not every offset is indexed. Instead of it, every n byte means after n byte it return to log file. It create one index row. So for example, if you will see here, offset 0 event size is 300 bytes. Okay, I understood. Offset 1 event size 500 byte. Offset 2 1000 byte. Offset 3 2000 byte. Offset 4 500 byte. Now segment size is only 1 GB, which is 4096 byte. So if you start adding here, so it's like 300 first, second is 500, third is 1000, fourth is 2000 plus 500. So if you will see the fifth one, which is fourth, it's crossing 4300, which is more than 4096. So it should go to second segment. So if you'll come here, segment 1 0.0, it is like till here it's 3800, 1000 plus 1000, 3000 plus 500, 3500 plus 3800. So segment 1 contain offset 4, which is it should contain 3 here rather than 4. Yep. And 3800. So it was like if you'll see, it is a size based partition, 1 GB. Now what we can do, producer can pick one of the different algorithm to decide which partition of the topic should be sent. Now we have another key based partitioning. What is key based partitioning? All the event from the same key will go to same partition. How we can note that? So if you will see here, suppose we have a event called as order event, okay, with a topic name order event, with key as a order ID and event as a order JSON. Okay. Now how we will create, how we'll get to know in which particular partition we need to send. So we understood about segment, but we don't know like whether it will go to P0, it will go to P2, P1, P2. We also need to know, right, which partition it will go. So what we'll do, suppose order ID is 1, 2, 3. So it will calculate hash of this particular, and then since the order we are creating on the basis of key, so suppose the same order ID always goes to that same partition, because the hash value mod the num of the partition, number of partition, like suppose here 3 partition is there, that's why 3, it will be always result the same number. So all the partition with the same key, sorry, all the event with the same key always go inside the same partition in the key based partitioning. Okay. Second is round and robin manner. So what is round robin? It's like event distributed, but no, order is not guaranteed related. Event may go to different partition. So here suppose we don't have any keys, so how it will work? Suppose we don't have something called order ID here. Here what we have, just order JSON. So it will just like E0 will go to partition 1, then partition 0, then 1, then 2, like that we can follow the trend. So first one was the key based, second was round and robin, and third one is custom partition. So we can also write our own custom logic. Suppose country India got partition 0 and country US got partition 1. So it like custom any logic you can write. So we understood, okay, how the offset is decided, how the partition is decided, how the segment is decided, everything we got to know. Now suppose this is topic, but we can see one more box is there outside. What is this box? So box is broker. A broker is a single Kafka server instance. Okay. A broker is one which actually store data and serve clients, producer and consumer. So if you'll see here, it's coming into broker only. And consumer will also take from broker itself. A broker stores some partition of some topics. Okay, understood. It's like straightforward, we don't need to go inside. Important note, topics and partition are distributed across multiple broker. That's why I said one broker store only some partition of some topics. So it do not hold all the topics. Also, it do not hold all the partition of the topic. Seem confusing? No problem. We have some diagram below where we will understand what it trying to explain. But yeah, we'll come back to this particular multiple broker thing very soon. So if you'll see here, as I said, there is a we'll understand multiple when we'll see Kafka cluster later in the topic. Yeah, same thing. So now what we are seeing here, producer is publishing one event inside the Kafka broker, and Kafka broker is then Kafka broker is taking that particular event and pushing it to this particular topic. So if you will see here, we have different case. We also have consumer now. So what is consumer? Consumer is like something called as a we have placed order, right? Uh, any other service which is receiving that particular event that we have the order is placed is consumer. So we have like consumer group 1, consumer group 2. So it's a notification which push them notification into our mobile that order is being placed. It is analytics. Analytics is something called which let the business know that how much profit, how much loss. Every analytics it used to measure. So we have different uh, consumer. So there are some rule for consumer. What is the rule, bhai? In one consumer group, same partition is not read by multiple consumers in one consumer group. So this is consumer group 1. So we can say this is one consumer group which is notification. Same partition cannot read by multiple consumer. So this is inside one consumer group. Consumer 1 is there and consumer n is there. So these both cannot read from same partition which is P0. This is one of the rule. Okay. So if you'll see, we have three partition. Consumer 1 is taking from P0. Consumer n is taking from P1. But if you'll see here, consumer group 2, it is a different group. So it's again subscribing to P1 partition. Understood? So here we can see it's one partition is consuming by different consumer, but the group should be also different. But suppose this consumer n is also part of second consumer group, we cannot subscribe to the same partition. Okay. So what if consumer is less than partition? It's very straightforward, right? So if suppose consumer are less, then each one will take one. So if you'll see consumer 1 partition 0, partition 3, like multiple partition you can subscribe. So consumer 1 have subscribed partition 0 and 3, 2 have subscribed 1 and 4, and 3 have subscribed 2 and 5. But what if consumer is more? Because you cannot subscribe to same partition if you are there in the same group. So at that time what you will do? You have to make those particular consumer which is extra as idle. Okay. Now this is only one consumer group. What happens in multiple consumer group? Same partition can be read by multiple consumer present in different group. That we have already discussed, that different consumer group can fetch from same partition. Okay. Now each consumer group maintains partition wise offset independently. Yeah, we understood that uh, each consumer group maintain partition wise offset independently. So it is, suppose it is running, it consumed consumer n consumed till second offset, and consumer 1 only consumes till third offset. So both of them are reading from P1 independently. Okay. uh, okay, same thing they have explained here. Okay, now how they maintain those things, that from till where, till which offset I have read. So consumer group offset information stored in Kafka means there is a default con topic which is being created for it, which is called underscore consumer underscore offsets. Okay. Okay. These consumer group offset stored in this. Okay. This N means literally internal. This topic is internally created by Kafka. So yeah, this is the internal topic, and it's have 50 partition by default. So everything can be stored inside that particular. So if you'll see here, we have producer one, we have some topics. This is the internal topic of Kafka, and we have a consumer. What it is doing, it is publishing. So it is, if you will see here, what publish message contain of this after it get consumed, that consumer offset. What is the notification group ID? It is the notification group ID, right? Then message, and if you'll see here, committed offset. So if you'll see here, compute the partition. So how it will get to know which partition it will fetch. So notification group ID, it will calculate the hash, and it got to know it will have to take from 23. So all the offset update for particular consumer group 23, notification will go to partition 23. So all the group of that particular consumer group, it will fetch from partition 23 only. It can't take from any other thing. Okay, because it is a group ID of that particular consumer group. Okay, this committed offset strategy help consumer got crashed. Say new consumer comes up. So suppose I am consuming this particular partition, and I have consumed till 3, and this consumer got crashed. So how I will get to know till where I read? So everything is being stored inside consumer offset. From there I will get to know, okay, from that particular place, this much offset I have already consumed. After that I need to consume it further. Okay, come to the next. Broker internally maintain the key value map from the, so everything is done by broker. Okay. Okay. So what are, we have some different strategy of offset also. Strategy one is auto commit. So every 5 second it gets committed whatever it have read. But suppose time 0, it's 0 to 99. Time second, consumer processing event. Time fifth second, auto commit triggers and commits offset 99. 6 second it got crashed, but only 50 is processed. So we lost 51 to 99. Why? Because it will restart from 100, because if you see commit offset at 99. So what we used, we don't use some manual commit, auto commit, we'll use manual commit. So we'll poll event 0 to 99, we'll process all the event properly, then we will commit offset 99, and we will wait for the confirmation. Once the confirmation is done, we will continue to the next branch. Okay, then that's all for the today. More advanced topic which is cluster, then we can see multiple brokers and all, that we'll discuss tomorrow. What we have learned today is basics of Kafka, you can say, which contain Kafka broker, producer, topic, partition, offset, segment, commit strategy, many things we have discussed. So yeah, that's all for today. If you like the video, please like, and if if you want any improvement in the video, please do comment down in. And also, again, big credit to Concept and Coding by Shreyans. Uh, because of him, I am able to create this video. Otherwise, I would have not. So that's all. Bye, guys. See you tomorrow.